Stan Gibilisco here with a little information, a little more tutorial from my book Physics Demystified, second edition. What you're looking at here is the preview page on Amazon.com. In the description of this video, I will provide a link to the Amazon page for this book so you can see this preview, look through the book in the front matter at least a little bit, and decide whether maybe you might want to purchase it. However, at this point, my main porpoise is to show you something very interesting from chapter 12 in the book. It's figure 12-7. What we have here are two acoustic wave disturbances, compression waves. At A, we have a wavelength or a frequency of F, say 1 kilohertz, superimposed on something that's 1.1 times the frequency, or in this case that would be 1100 hertz. Notice the beat frequency signal, which has a frequency equal to the difference between these, which would be 1/10 of F, shows up quite clearly in this drawing just because of the nature of the way I've drawn these lines. You can see that this compression wave here, the beat frequency, appears quite clearly. Here we have a wave at a frequency F, say 1000 hertz, and 1.2 F, say 1200 hertz. And again, the beat frequency wave shows up quite clearly. And finally at C, F and 1.3 F, say 1000 hertz, 1300 hertz. The 300 hertz beat frequency wave shows up again. Not quite as neat as it is here, but all I did really was just draw these vertical sets of lines, which I manufactured painstakingly to create this particular illustration. Now if I expand this out to 1.1 times its width, then these two waves have identical frequency. Let's see what happens now if, say, I expand this wave. Let's get rid of this because it no longer applies. Let's suppose now that I expand this wave by just 2% horizontally. Notice what happens. A beat frequency wave once again occurs, and it's quite low in frequency, as you can see. Let's go back, undo edit properties. Let's make it 3% greater in frequency. Notice that slight little bit of increase there, and then we can just sort of gradually work our way up like this, increasing it by, whoops, okay. Undo edit properties, let's try that again. These little tiny figures in here are hard for this old man to get a handle on. See that? Now ain't that the coolest thing since Big Island Bakery sourdough rye bread? But it shows you very clearly how beat frequencies can occur in sound. And one should note that when you listen to the music from an orchestra or a band and all these instruments are playing together, you're not only hearing the notes from the instruments themselves, but you're hearing these beat frequency notes as well, whether it's the same instrument, say 2 trumpets, or 2 violins, or whether they're different instruments, say a violin and a trumpet. You'll always get subtle beat frequencies in there, and it contributes to an immensely complex jumble of waves, which somehow your ears processes into something that makes you happy. Now, if that ain't even cooler than sourdough rye bread could ever be, I'll be a rat's patootie. Stan Gibilisco signing off, once again making a little pitch for my book, Physics Demystified, 2nd edition, a link to which you will find in the description of this video. Until the description for this video and of, by, and for, all right? Until next time, so long.